Hello बच्चों, so we are continuing with this very interesting topic in which we had already discussed that how do we assign frequencies for the IR bands in a triatomic molecule. Next here we will be discussing about how do we first of all find the reducible representation for the degrees of freedom for a tetrahedral pentaatomic molecule, and then how many vibration modes could be possible, and what will be the different irreducible representation corresponding to it, and how do we assign the different frequencies. Now, in a tetrahedral molecule or triatomic molecule, we will be using the shortcut method, and in this shortcut method what do? We have to determine these two values, Ni and Xi. Ni represents the number of atoms whose position remains unchanged during a symmetry operation. So when we consider the identity operation, as you know, identity operation means we are carrying out no change. So if we are carrying out no change, then the position of all the 5 atoms will remain same, and thus the value of Ni will be equal to 5. But if we consider the rotation along the C3 axis. Now, if we take the example of methane molecule and we carry out rotation along the C3 axis, then on rotating, we find that the position of one of the hydrogen atom and the carbon atom remains same, while that of rest of the 3 hydrogen atom changes. So there are 2 atoms whose position remains unchanged. Thus, Ni value will be equal to 2 against the C3 operation. In the case of C2 operation, if we consider the C2 operation, as you know, the position of C2 axis lies between the 2 hydrogen atoms. And when we carry out rotation along this C2 axis in this manner, then position of all the 4 hydrogen atom is changing, while the position of carbon remains same. So there is only one atom whose position remains unchanged, and thus the value of Ni corresponding to C2 will be equal to 1. Similarly, if we consider the S4 axis, which is collinear with the C2 axis, here also the position of carbon atom will remain unchanged, and thus the value of Ni will be equal to 1. In the case of dihedral plane, actually the dihedral plane passes through the 2 hydrogen atom and 1 carbon atom, and it bisects rest of the 2 hydrogen atom. The plane lies in this manner. So when we carry out the reflection, the position of these 3 atoms, this hydrogen atom, this one hydrogen atom, the carbon atom, and one of the hydrogen atom which lies in the plane, their position will remain unchanged, and thus corresponding to the dihedral plane, the value of Ni will be equal to 3. So the value of Ni can be obtained in this manner. Now if we consider the character table for the tetrahedral point group, then here we find that the irreducible representation T2 corresponds to all the 3 unit vector x, y and z. ट्राइएटॉमिक मॉलिक्यूल में जो C2 पॉइंट ग्रुप था उसमें हमने देखा था x कोऑर्डिनेट, y कोऑर्डिनेट और z कोऑर्डिनेट के जो यूनिट वेक्टर्स हैं, they corresponds to 3 different irreducible representation. Here all the 3 coordinate are present in the same irreducible representation, and thus they are degenerate set of unit vectors. Thus there is no need of considering any other irreducible representation over here. So against the xi value, we simply write the character corresponding to T2 irreducible representation, that is 3, 0, -1, -1 and 1. So if we substitute these values, then we will be obtaining this condition corresponding to identity. The value of xi will be 3. For C3 it will be 0. For C2 it will be -1. For S4 it will be again -1, and sigma d it is 1. If we carry out the product of these values along vertically, then for the 3n degree of freedom, the complete total degree of freedom, the reducible representation which we obtain is equal to 15, 0, -1, -1 and 3. And when we carry out reduction of this reducible representation by using the formula which we have learned in the first semester itself, then the corresponding irreducible representation which we obtain will be equal to A1 plus E plus T1 plus 3T2. So these are the irreducible representation which are component of this reducible representation for 3n degree of freedom. As usual, जैसे हमने triatomic में भी लिया था, once we find all the complete degree of freedom for the molecule, we subtract the rotational component and then the translational component. So among the complete 3n degree of freedom, from the character table, we know that all the translational component corresponds to unit vector x, y and z, which corresponds to irreducible representation T2. Similarly, all the rotational vector Rx, Ry and Rz, they correspond to irreducible representation T1. Thus, the translational degree of freedom is represented by irreducible representation T2, while the rotational degree of freedom is represented by T1. When we subtract these two values from the total degrees of freedom, that is, we are subtracting 1 T2, so this value will reduce from 3 T2 to 2 T1, and the rotational corresponds to T1, so we have to remove this value T1. So vibration degree of freedom will be represented by irreducible representation A1, E and 2 T2. So these are the irreducible representation which corresponds to the normal modes of vibration in a methane or any tetrahedral molecule. Now, on the basis of this, we can say that the molecule will be having around 4 bands. One band corresponding to A1, then there will be one band corresponding to the irreducible representation E, then there will be two bands corresponding to irreducible representation T2. And the condition will be that in E, which is a double degenerate term, there will be two vibration motion, which will be having equal energy. And for T2, there will be 3 types of vibration motion, which will be having equal energy. Now, how do we explain these conditions? So if we consider a tetrahedral molecule, so the symmetric stretching taking place in the molecule will correspond to A1 irreducible representation. In this case, symmetric stretching किस तरह से होगी वो अगर हम देखें, along the central atom, जो हमारे 4 hydrogen atom attached हैं, they will be undergoing elongation and compression simultaneously. It is similar to an heartbeat like this. They will expand and then contract. They will expand and then contract. So that will be a symmetric stretching. So this will corresponding to the irreducible representation A1. In the case of E, there are 2 types of vibration which can take place, and both these vibration will be having the similarity as we carry out the skating on a spherical surface. Skating में हम क्या करते हैं, पहले एक सीधा मूव करते हैं हम इस तरह से, और फिर एक पैर हमारा इस डायरेक्शन में जाता है और एक पैर इस डायरेक्शन में जाता है, तो इस तरह से हम स्केटिंग करते हैं. उस तरह का मोड है जो यहाँ पे हमको मिलेगा. एंड यू विल फाइंड दैट these 2 atoms are moving in this and this direction, then this atom is moving in this and then this direction. Similar condition you will find over here also. Clear? These 2 atoms, अगर हम इन दोनों को consider करें, they are moving in this manner and they are moving in this manner. So both will be corresponding to the irreducible representation E, and they will correspond to frequency mu2. Similarly, there will be 3 triply degenerate terms. In this motion, you will find that in the first mode, the atom, the central atom, that is carbon atom, it is moving towards the negative x-axis, while all the hydrogen atom, they are moving towards the positive x-axis. Okay? Similarly, here you will find that the central atom, carbon atom, it is moving along the z coordinate in this direction, while the hydrogen atom, they are moving along the z-axis in this direction, in opposite direction. Similarly, in third mode, you will find that the central carbon atom is moving along the minus y coordinate, while the hydrogen atom they are moving along the plus y coordinate. So this type of motion is an unsymmetrical stretching, and due to unsymmetrical stretching, all these three modes will be having equal energy, which will be designated by symbol nu3. Then lastly, there will be again a triply degenerate motion, and here you will find that the two hydrogen atom, it will be a bending kind of mode, in which you will find that the two of the hydrogen atom will be moving towards each other, while rest of the two hydrogen atom will be moving away from each other. Here these two hydrogen atom are moving towards each other, while these two are moving away from each other. In second case, you will find that these two hydrogen atom are moving towards each other, while these two hydrogen atom are moving away from each other. And in third case, again these two hydrogen atom are moving towards each other, while these two hydrogen atom are moving away from each other. So these are again bending modes of equal energy, which will be designated by nu4. So in a tetrahedral molecule, what will happen? We will be having four type of bands, out of which one will be singly degenerate, one will be doubly degenerate, and two will be triply degenerate.